show how to use Excel spreadsheet to do these tables to figure out both the Hamiltonian method and the Jefferson method for figuring out how to apportion representatives or to do the school teacher apportionment. And so I'm going to do this here in a spreadsheet. Now I look at this and it looks pretty much like a spreadsheet already. So I think whoever made this did it in a spreadsheet. So they have the state and they have the population. And then they had the standard quota. And they had the minimum quota. And then they had the fractional remainder. And then they had the final apportionment. Okay? And up here they said this was state A. Back here. I'll even write that. State A, B, C, and D. And there was totals in this column. Now, in their example, they said there was 936 people in state A. That could be 936,000 people in the state A or whatever. But we'll just go with 936. And then it had 2726 and 2603, and this one was 3735. Now, totals are something you could pull out your calculator and get the total. They tell you it's 10,000, but on a spreadsheet, totals are nice that it does it automatically. If you just say, I want it to do a formula by starting with an equal sign, that means do a formula that I'm going to say. And I can say, add this one plus this one, this one plus this one plus this one plus this one. So I just click on the cell and it puts its address, E2 or D2 or C2, and that's what it's putting there. And that would give me the total. And it was the 10,000 there, it's the 10,000 here. The other way to do it is to say, I want it to be equal to the sum, parenthesis of these cells. And I can just highlight the cells by dragging across and selecting them, close parenthesis, and it does the sum. Now, there were two standards. First, we have to find the standard divisor. Now, they said that the number of representatives was 100. Now, we may want to change that. So I'm making that a separate cell so I can change that number. And then we would take the number of representatives and divide that into how many people there are so that I know the number of people one representative represents. And that's called the standard divisor. And it's the total population. So I'm doing a formula now, so I got to remember to start with equals this box divided by that box, or cell as they call it in in spreadsheets. So if I do that, 10,000 divided by 100 representatives means there's 100 people represented by each representative. Now notice that if I said, what if there was 102 representatives, then 98 people would be represented by each one because there's more representatives, so a smaller population will be represented by each. But let's go back to 100. And so then the standard divisor in this case is 100. And that's in cell C11 right now. So I go up here to find the standard quota. I take the population divided by how many people are represented by each representative to find out how many representatives that state should get. So this is going to be a formula now because I don't want to do the math on my calculator. This is my calculator, so I say I want this to be the population of that state divided by the standard divisor. And if I press enter, I get the 930. This is not the right one here. We want to go to another one here. Where is it? That was doing an adjustment. This, not that one. This one right there. 936 with 100 representatives. Okay, now to do the standard quota for state B, I have to take this divided by that, and I can rewrite the formula, but I did the formula here. And I can carry it over, except it's not going to work quite right because when I copy a cell over from one spot over to the next, it says, okay, this box was referring to this cell, and if I go one over, it's going to use this cell, which I want it to do for here. But it's also going to say, if the formula was referring to here, and I go over one, it's going to use this box. And I don't want it to. I want it to stay with this one. So to make that happen, I'm going to go back to this formula and say, always stay in column C. So I'm going to put for some reason they use a dollar sign. So if you put a dollar sign in front of the C, and then enter, then come over here and now grab a hold of that lower right-hand corner and drag it over, it will, you'll notice it'll stay in column C. So it's still using this one. Highlighted blue, it's using this box divided by that one. So to finish, I could have just gone here and said, I want to do that same thing all the way across. And notice it just divided each one of these by that 100. It stayed in column C, row 11. And so now I've got all those done. And how did they get this 100? They found the sum of these four boxes. They totaled those. Well, that's what this was, except I want it to be the next row down. So if I pull it down, it'll just do it for the next row. You notice now it's doing B3, row 3, to E3, row 3, whereas this one was in row 2. So pulling it down, it just did the same thing, but in the next row. Okay? Now, here, the minimum quota was, okay, every state should get at least that whole number, the 9, the 27, the 26, and the 37. That's the minimum they should get. So to do that, we need to throw the decimal away to get this row. In math, that's called truncating a number. So I write in equals, and I could try to write the whole word, but it's abbreviated in spreadsheets usually as TRUNC. You notice it picked up that function truncate. And if I put a parenthesis, it'll say, what number do you want to truncate? And I'm going to click on that box. So there's the number. then I can put a comma, and then I can say, okay, I want to have 1 decimal place or 2 or 0, but it's in brackets, so it means that's optional. So I'm not going to do anything there. I'm just going to go parenthesis, and then it's going to go with no decimal places. And notice it threw away the decimal part. And I want to do the same for each of these, so I'm just going to copy over by dragging across. So now you can see here, it says truncate C3. If I go click here, it says truncate D3, and so on. And here I want to add up these to see how many representatives are allocated. So that's the same process as this was, so I just copy it down. And it's allocated 99 of the 100 representatives. So we got 1 representative we need to give to somebody. So my decimal remainders we can get by just subtracting that from that. So I'm going to say it's a formula, so it's going to equal this box minus this box. And that says I got that fraction of a representative that this state is short. And if I copy it across, and that fraction for here, you see the 0.26, the 0.03, and the 0.35. And in fact, if I subtract these two, I find out how many representatives I got yet to distribute. 1. So I have to give this 1 to one of these 4 states. And here's where the Hamilton method said, give it to the one with the highest percentage, the highest decimal left. And so A would have got it. That's a little tricky to do on Excel, so I'll just type in. That would have been 10, and this one would have stayed at 27, and this one would have stayed at 26, and this one would have stayed at 37. And if I add those up, I get, this was a subtract those two, so I don't want that. I need to do the add formula. That was up here. Copy that, paste it there. There's now a formula that adds them up. Okay? So now we've got a table that looks just like what was in the textbook here. Okay. So now to understand the Jefferson method. Let's look at the Alabama paradox that would happen. They said, what if we go to 101 representatives? Notice this is how we would allocate, right? If we went to 101 representatives, which was that other table I was looking at to start with right here, there, they went to 101. Well, I'm going to do that right here. I'm going to say, okay, what if we got 101 representatives? That means the standard divisor is going to go down. And when we take each one of these and divide by this smaller number, we get these new set of numbers, which are identical to what they have here for 101 representatives. And if you truncate those, you get these numbers, the same numbers we had before. That's still only 99 taken up. Well, if we're trying to do 101 and we've only got 99, we've got 2 to hand out. Who do we give them to according to the Jefferson method? Well, the Jefferson method, or the Hamilton method, said the highest one. So 0.53 and 0.72 are the 2 highest. So in this case, 27 would go to 28. The 26 would stay the same because it's a lower decimal. And the 37 has the highest decimal, so it would go to 38. And this state has a lower decimal, and so it wouldn't have gotten any extra, and it goes to 9. So the Alabama paradox says if we go from increase the number of representatives, every state should not lose any representation. Some states will gain, but none should lose. And here's a case where if it was 100, state A got 10. If it was 101, state A got 9. And that was the Alabama paradox. So to solve that problem, Jefferson came up with a different method. It's almost the same. And let's go back here. So we go back to 100 representatives. And we're back to that other table. And he said, instead of just looking at the highest remainder, he said, okay, this is the standard divisor, but let's just tweak it. So now there's a formula in here. I put the formula, this box divided by this box. Now we're just going to pick numbers close to this. Instead of dividing by 100, let's divide by 99, which means only 99 people are represented by each representative. So that means each state will get a higher amount. So watch these decimals right here. When I divide by 99, you'll notice they'll get a little bit bigger. 36, 26, 3, 35. When I hit return, they go to 45 instead of 36, and each one got a little bit bigger. But it wasn't big enough to assign another representative. So Jefferson said, well, okay, maybe you need to go to 98. And these decimals got even bigger. In fact, this one goes from 37 to 38. And he said, okay, state D gets the extra one. So if you do this one, and then you go to 101 representatives, uh, 101. So now with 101, we should be allocating 101. Well, we're only allocating 100 right now. So he would say, well, let's divide by 97. And now we've got 101 allocated. And it didn't, state A only had 9 before, and it still has 9. And it avoided the Alabama paradox by just, instead of using the standard divisor, he used a modified standard divisor. Remember, the standard divisor was when there was 100 representatives, was 100. And then when we got that by putting this formula equals total population divided by the representatives. Yeah. Now, if you up it, but if you start messing with it, it's as Jefferson did, then it's called the modified divisor. And you can see down here where they did that. They said, okay, let's work it out with 99. And it didn't give enough, so then they went to 98, and it finally came up with 100, and it gave the extra one to state D, just like we decided it would go to D if we made this 101 representatives, and we decided to put in, if we were doing 100 for the standard divisor, the modified standard divisor, it only allocated 99 representatives. If we did 99, it still only allocated 99 representatives. If we went to 98, it got the total number to 100 and gave 38. And so this right here is this row right there. And if I put 99 here, I get this row. 4553, 535 rounds to 54, 29, and 72773 rounded. Okay? So, Hamilton method, once again, give it to the highest decimal. Jefferson method, take the standard divisor and modify it, and so you get modified standard quotients that finally go high enough to allocate all of the representatives. 100 didn't work. 99 as the standard divisor, making a modified quota with a little higher, but still not enough to allocate them. So it finally got it when we did 98 as the standard divisor. And that's how you can do this kind of stuff on a spreadsheet.